Ну, давайте начнем.
Let's begin. Our first speaker is Jignesh Shah. He works in Amazon. He came from the States to us, and it's going to be a big presentation of two parts. The first part is called Deep Dive on Amazon RDS, and the second was the tricks and trips of RDS Amazon. Now we start.
Okay, thank you for coming early in the morning. So how many of you actually use Amazon RDS right now? Just a quick show of hands. Okay. For people who have not used it, I do have credits available. So if you want to open an account, if you already have an account, you could actually use that credits also. It's available at the two edges of the table. Also, there are some stickers out there for you to try that out. So with that, I'm going to start. Good. Okay. All right. So the topic is Amazon RDS. But before I start about that, I want to briefly talk about Postgres quickly. Since we are at Postgres conference, I'm hoping everybody is using Postgres. Right, and if you're not, do use it. And actually, Ole did mention to me that Postgres is actually more popular than MySQL and other open source database in Russia. So this is definitely a place to be out there. It's one of the things that I would like to see where Postgres is actually beating all the other open source databases out here. So without much things to go deeper into Postgres, what I'm going to talk about is how you're going to deploy Postgres. So if you look at Postgres, there are actually three ways you can actually deploy Postgres. You could actually deploy Postgres on your own, which typically is termed as on-premises usage. There are two other ways that you can also use, especially with the cloud providers now being popular out there. One of the ways you can use them is actually using it on a hosted environment kind of thing. So think of it like an Amazon EC2 instance, where you get an instance and you deploy Postgres on your own on that operating system and use it. Then there is this third way of using, which is often termed as managed service. And Amazon RDS is an example of that managed service. In a managed service environment, what you really get is an endpoint where you use directly the database that you're using, and you do not really have to kind of worry about the operating system and the hardware, and other than like assigning the resources out there, right? So let's actually first talk about like, what are the benefits of using Postgres on EC2. Even if you use Amazon EC2 directly, you are definitely getting all the advantages that you typically get with the cloud environment, where it's very easy to provision an EC2 instance. You basically just log into your account and spin up an account, EC2 instance, and once you get a shell SSH into it, and you can install your own Postgres version and manage it as you want it. One of the big advantages of using directly on EC2 is you can actually deploy any specific version of Postgres. You can build your own Postgres, build your own extensions and use it, right? Though the typical things that you take on us with that is you will be responsible for actually managing your own upgrades and any patches that you need to apply. So the advantage of using a managed service is most of the things are actually automated for you, where you basically give the command through an API interface and execute those typical DBA operations that you are kind of used to doing it, right? It's kind of said, as a DBA, you like to do it once by hand to learn how it works. But once you have learned it, it's no fun, right? Then you just want to automate it. So think of managed database service actually giving you that same feature as such. RDS actually is kind of supports multiple databases along with Postgres. On the Postgres side, we actually have two flavors. One is the open source version of Postgres, which is typically termed as RDS Postgres. And then we also have Amazon Aurora with Postgres compatibility, which is, think of it as an open source based Postgres with enhancements, specifically the Aurora storage out there. In this particular presentation, I'm going to talk more about RDS, and I'll probably touch a little bit on Aurora out there, but like Aurora typically is a presentation by itself. If you want to know more about it, I'll be here all day. We can talk about it after the talks today. The other benefit of actually using a managed service is like, security and compliance. What we have heard from people is like, security is typically one of the highest priority for customers. And hence, even at AWS, we have made that to be our top priority. So everything kind of like, if you look at how AWS deploys things, security is kind of like the topmost priority out there. And then comes like the ease of use and performance and other things out there. So that's how kind of like we typically rate. Like if you are prioritizing things, we actually prioritize security at the top things, right? So the next few slides I'm going to go about like how security in RDS works using the AWS framework, right? Now, typically when you deploy Amazon RDS instance, you get the endpoint. Now, there are two ways you can do the endpoints. You can say it's publicly accessible, which means you are able to access it anywhere from the internet, or you can say you want to deploy it in a private environment, which typically in an EC2 environment will be called a VPC. So even if you deploy it in a public environment, your first level of security is something called security groups. So by default, an instance is not accessible by anything outside whatever is mentioned as part of your default security group. And the default typically is pretty much restricted. Nobody can access it. So once you deploy it, you actually edit your security group and add the clients that are allowed to connect to it. And there are multiple ways you can do them. You can actually add them either by IP addresses, or you can add them by a subnet if you want. Another cool thing that is also supported is you can actually predefine a set of resources that you are using in a different security group and add that security group into the instance that would be managing your instance. So it instantaneously kind of allows you to say, hey, by default, when you deploy it, it's fully secured. And then you basically add your security group for all the clients that would be accessing it as part of this group, and now they can connect to it. So this is kind of like the first layer. Typically, you would see that people kind of like, to make it easy for themselves, would say, hey, 0000/32, which means anybody can connect to it. While that's actually very easy to use to allow when you're starting to learn about RDS and the connectivity, it is not really recommended, because what that allows is like any client can connect to it, and you don't really want to do that. So a typical idea would be to kind of like either do it by a subnet or by the security, like a limited set of group that would have access to the instance. The next thing is VPC. Like I said, like you can also deploy your instance in a VPC environment. VPC is like a virtual private cloud, which means you are actually making it accessible only within your own organization. To kind of get an idea of VPC is like AWS has the concept of availability zones, which are kind of like set of resources assigned together. A typical availability zone is part of like a single subnet. A VPC would kind of encapsulate multiple subnets into its own network as such. So that means like you can actually have applications within the various subnets as part of the VPC talking with each other. So together with VPC as a protective layer across your security groups, you can actually now do fine-grained control on who will be able to access your database out there. The next thing that RDS also supports is encryption at rest. Now, this is actually a common compliance requirement nowadays. Like anytime the data hits the disk, it needs to be encrypted. So nobody, even if they steal the hard disk, can actually read from it, right? So AWS, when you deploy it, actually provides a very easy way to kind of say enable encryption at rest. And it uses the AWS KMS system, so by which you can actually either create like a default key to kind of encrypt your database, or you can actually use a dedicated custom created key to deploy and encrypt your instance. Now, one of the things of using a custom key is if you're trying to share a snapshot by copying that snapshot to a different account, if you have a custom key, you can actually provide the key to the different second account and be able to restore from it. So it's actually a good idea to use like a custom keys instead of the default key that you can also use out there. So taking all these concepts of security and actually applying them together, this is at the end of the day, this is what you would get, right? You would actually have set of applications that are connecting to your database. And the database itself is writing to a bunch of database files which are encrypted, which are like kind of lying on the disk, right? So now typically the first thing you're doing is doing the security group around your DB instance. So you're kind of restricting who connects to it. Then you are using the SSL connections from your client. That means anything that's transmitting over the wire is also encrypted. And on top of that, when you put the VPC around it, you're basically kind of limiting and making sure that nobody outside that VPC can connect to that instance. So even if there are kind of like rules that you have that are kind of allowing more than you originally intended, you are kind of encapsulating it only within that VPC. And at the end of the day, like using the encryption at rest, you are always protecting it, even the files that it writes onto the servers. Now, one thing to be aware, in Postgres, if you use the PSQL client, there is an option to disable SSL by using the option SSL mode disable, which would allow you to kind of open an unencrypted session from the client to the server. What we had heard from many customers is that they don't want the clients to be able to make that decision for the server. So on RDS, what we also support is an additional parameter called RDS Force SSL 1. Like when you enable that option, basically anytime an unencrypted client connects to the server, it will close that connection down. So this would make sure that the clients will always have to use SSL when they connect to the server. This is actually important for many compliance reasons where you want to make sure that anytime you're transmitting over the network, it's always encrypted, and this would actually allow you to kind of do that. The next thing I want to talk about is identity and access management. In AWS, we also support what is known as IAM, which typically you can actually use that right now more on the CLI or the console side. So think of it like anything related to the database instance, you are actually controlling to a granular level on who can do what operation. You can actually have IAM users which would only allow people to take backups, but kind of ensure that they never delete the database, right? So it kind of gives you like granular permissions to say who can do what. Now, typically, the thing to keep in mind is that only operates at the API level, which means whenever you're using the AWS CLI or the web console, right? What typically Postgres does is like the database users, which are directly defined in the database itself. Those are not by default controlled by IAM. So whenever you create like a user using the PSQL, that is what is known as termed as the database user. That itself doesn't kind of like tie back to IAM. So in recent versions, we now also support what we call as IAM integration, where you can actually say, I want to map this database user back to this IAM role, and then use the IAM credentials to log into the database. So the way you would do that in the recent versions is you would create a database one time and assign the role called RDS IAM. Once you do that, the password within the database is kind of like neglected, and anytime the connection happens from PSQL, it will actually authenticate with IAM, which means the way you would actually use with IAM is you would use the AWS RDS get temporary credentials for that IAM user and use that credential as the password to log into the database. So this gives you kind of final control on you want to get like access to kind of say, hey, I want to do password rotation. I want to make sure that I have a centralized user database that kind of guides policies on all the users. So you can do that with IAM. Other thing is, like, even if you don't use IAM, there are other ways you can actually use them, and I'll talk about that in my next presentation on the tips and trips out there. Now, going to the next thing is, like, we have talked about security, and the next thing I want to talk about is, like, how do you kind of simplify your deployments? Now, we all know, like, Postgres has a bunch of parameters which are typically called the GUC parameters. In RDS, the way you would use them is using something called the database parameter groups. The database parameter groups is kind of a collection of these custom GUC parameters that you can set. Now, if you think about it, right, you would want setups that are typically for testing, and then you would want different parameters that you're typically doing for your production setups. So, like, the example I'm showing out here is you can actually create a custom parameter where you would enforce, like, force SSL to be enabled. You may want to kind of like preload the libraries that may be needed for your extensions. PG audit, like, is an extension that is popular if you want to use, like, compliance to make sure all your queries are logged, right? And you can use that as your default set of parameters. So the next time you deploy a production environment using this parameter, you know most of those policies are already set for you in that deployment. So database parameter actually helps you in a way to kind of get like a consistency in all your production deployments, test deployments, and out there. And it's kind of very useful for that, like, so you don't kind of miss out on things. Like, oftentimes, like, hey, in all my production setups, I want the PG stat statements to be enabled, right? The way you would do that is you will create like a production parameter, make sure that the library is always preloaded for you, and then you deploy it, the library would be available out, in all your production setups. So that's a good way of doing that. Another useful feature of RDS is the ability to quickly change your disk, your instance type, and also increase your disk size, right? We do support different types of instance. Typically, the three types we support are T, M, and R. And if you typically look at it, like, T's are kind of like the low-cost options, but it definitely has like more flexibility out there. The M's are general purpose, and R's are like kind of high memory, higher density of memory. So if you look between M's and R, like, M's would be 1:4 ratio of CPU to memory, while R's would be 1:8 ratio of CPU to memory. Most of the time, I've seen people deploy more M, but like larger instances where you actually have many connections, you would typically go for an R instance out here, right? On the same style, we also have two types of storage. The most general purpose is like the GP2, which are also like kind of like useful out there for the most general cases. And typically the way you would do that is you would start small. Typically, if you use the console, you start with like a 20 gig instance, and you grow them as needed. Now, one thing to keep in mind about the GP2 instances, like the I/O performance that you can get on the GP2 typically depends on the size of the GP2 you have. There is a kind of a rough rule of 3 I/Os per gig. So if you want to kind of like go to like a higher I/O out there, you want to kind of increase your size of the GP2 instance. If you are kind of very keen on getting like a consistent I/O performance, you can actually use the IO1 data storage type, where based on the size, you are kind of like getting a high degree of guarantees on the number of IOs you can actually achieve on these instances. The largest size that we support on both these things have been recently increased to like 32 terabytes now. It used to be like about a year and a half ago, we only supported till 6 terabyte. Last year, we bumped it to 16 terabyte. And just recently in November, we bumped it to 32 terabytes. So you could actually go to pretty large size with like 96 vCPU with 768 gigs of RAM and a 32 terabyte database store out there. And you'll see that it's kind of like a pretty powerful system at that point of time, right? Next thing I want to talk about is automated backups. One of the things to know is like by default, when you enable automated backups, you also get the feature for doing point-in-time recovery. The point-in-time recovery period that you can do depends on the number of days you have enabled for your automated backup windows. So if you enable for, say, 35 days, the full length, then you can do point in time anywhere between like 5 minutes before to like 35 days and do a restore out there. If you look from the behind the scenes perspective, the way the backups are done is like kind of like this classic storage way where you actually have discrete snapshot backup times and then the point in time wall log files. So the way the point in time thing works is you use like your base backup with that snapshot time and it will do a roll forward to the time you select in that window. So if you are kind of worried about restore times, picking something closer to the snapshot time itself or little bit later after that would be a way to kind of cut down your restore time out there. The next thing I want to talk about is multi-AZ. So RDS also gives you kind of like a one-click way of doing high availability. The way you would achieve that on RDS is like what we say is enable multi-AZ. So what it does behind the scene is like whenever you do a multi-AZ enable on your instance, it takes your instance. On a secondary instance in that same region, it would allocate another instance out there and start replicating. The replication typically happens at the storage layer, so it is always synchronous. So anytime you have the write commits happening on your storage, it will be replicated to this secondary instance out there. And because the way we want to make sure that it's always low latency for you, it is not really available to the user out there. So it's really a kind of like a warm standby, which is not accessible till there is a failure out there. So considering that example, right, you have an application that you're talking to this database instance, which is multi-AZ enabled. So all your applications are talking to your primary. Right, you could actually put your applications also on both the AZ and kind of use them. So that way, you actually have more resiliency, not only for your database instance, but also for your application. So if something goes wrong, right, because we have synchronous replication, what will happen is an internal heartbeat detector will detect that if there is a failure on your primary, it will take control, make the secondary as your new primary, and now it will start kind of moving all the applications to this new secondary. And how does it do that? So if I remember, like I said, like you always get an endpoint. The endpoint is like a DNS address for you. So when the failover happens, basically that same heartbeat also updates your DNS. So what your clients may see is like a disconnect. And when they try to reconnect, they will go back to the DNS, and the DNS will give them an updated IP address for that failover instance. And once they get the new IP address, they can now actually start connecting to the new instance. And it is kind of like it's pretty much automated. There is no humans involved. And we have seen like a typical failover happen like in roughly about 60 to 65 seconds. That's what you would typically see. So like within a minute when you attach, you would see that your database is back up. And because it is synchronous replication, there is actually no loss of data between the two. The time you disconnect and you connect back, there is no loss of data. Now, the advantage of actually doing your applications on both the AZ is like even if the whole AZ dies for some reason, like typically that could be like a network outage that may happen out there, your basically all your applications are working without any interruption to you. The database is responding out there. The beauty about multi-AZ is when it will get back, it will also try to kind of reset the secondary, the old primary and reset it so that you come back to that protected state. So now the next time the failure happens, you can now do the same thing and fail back if you want. So this is how kind of like a very easy, you just enable it and you actually get high availability. The SLA that we actually provide right now on this is 99.95% of that. The second way also that you can do scale out strategies on Amazon RDS is by using read replicas. Like if you know in Postgres does support synchronous read replicas as well as asynchronous read replicas. In RDS, whenever you create a read replica, it is asynchronous out there. Now, the reason for using a RDS read replica is primarily for two main reasons. One is to kind of scale out your read workload. So you can actually kind of offload your master and use the servers, run the read queries from the secondary. The second thing is also for like doing cross-region read replica, where you are basically trying to bring data closer to the consumer of your applications if they are in different geos. Now, the good thing about read replicas in RDS is they work in conjunction with multi-AZ. So both multi-AZ and the read replicas can be used together in a kind of like a different way. So if I try to explain, I've talked about like application can all connect to a multi-AZ. You can actually now spin up 1 to 5 read replicas out here and offload your read queries to the read replica. Now, for example, say, one thing to keep in mind is like from the application point of view, because these are asynchronous, it kind of follows the eventual consistent read. So if your application is sensitive to kind of doing like a write and a read immediately, then you always want to do that on the master. But if your applications are like doing OLTP out there and then running like the reports on a different thing, they can all run off from the read replica. With multi-AZ out there, the beauty is like even if something happens to your primary instance, and because the multi-AZ instance will take over the primary role, the advantage of using read replicas in RDS is they will now automatically follow the new primary instance in the multi-AZ. So there is nothing you have to do manually on your part to kind of change the mapping to the new instance. Multi-AZ will take care of your connections for the primary master instance, so your clients doesn't need to be changed at all. Now, one of the things we do allow you to do is like even in this configuration, you can actually still do upgrades, the minor version upgrades of that together. So typically the recommended way is you upgrade your replicas first and then your multi-AZ instance. Right? One advantage that you get with read replicas is you can actually modify the read replica to be a different instance size and use different parameters out there. Now, you don't really want to use different extensions on it, but you can use different parameters like different work mem for your queries, tuning, and other things. So you can actually assign different custom parameter group to the read replicas depending on the workload that is running on it. Like I talked about it, like cross-region read replicas are also used for kind of like bringing your data closer to your workload which are working in a different geo. A lot of people also use cross-region read replica for their DR strategy. So think of it this way, like you are already kind of like having a setup with a multi-AZ and read replicas working. You now create a read replica which is completely in a different region. For example, if the whole region is inaccessible, what will happen is you can actually plan a DR to that new region. The way you would do that is you would stop workload on your primary instance. Once the workload stops, like you would just wait for the cross-region read replica to catch up. Now, once and there is actually a CloudWatch metric that you get to see how far behind it is. Once it has caught up, you can now actually promote the cross-region read replica and make it as an independent primary and switch your endpoints in your application to point to this new primary in the different region. Typically, most people would also deploy the applications also in the new region, so it's better off like just migrating your applications or creating copies out there in the new region and connecting to the new primary out there. One of the things we do support now is ability to create a multi-AZ read replica, which means like if you're failing over for DR, you can actually convert it to multi-AZ before you fail over, so you're always in a protected state. If you haven't converted that already to a multi-AZ, once you promote, you can also convert it into a multi-AZ instance, so you now get the same production SLA on that one too. And it's basically like, doing a DR move now is simplified to basically create a cross-region read replica, promote, and like move your applications out there. There is no fancy planning to be done. You can actually test it out as much as you want by creating a cross-region and doing your own DR test by promoting it out there. One of the things I did mention briefly when I talked about read replica is like we do support minor version upgrades. The way minor version upgrade works is, think of it this way. It's essentially the same thing that the community recommends. We shut down the instance, upgrade the binaries on them, and when you start up, you now actually get the new instance. So from a user point of view, anytime you do a minor version upgrade, you would essentially see kind of like a reboot happening, and you now are on the latest version. You can also upgrade instances, like I said, if you have read replicas, and the preferred way would be to kind of upgrade the read replicas first to the latest minor version and then upgrade your master instance. RDS also supports one-click, one operation major version upgrade. So you can go from, say, version 9.6 to 10 by doing an operation call. And typically the way you would do that is like, before upgrading, you would want to kind of like create a new instance from a snapshot and then do an upgrade process. Make sure all your applications are working with this new version of Postgres. And once you are satisfied with your testing, you can go back to your primary instance and say, upgrade it to the next major version out there. Typically, I've seen like it takes about 15 minutes. Behind the scene, it actually does like a PG upgrade on those instances and get them to the latest version. And you'll be able to use them. There is actually not much thing out there. It is kind of like everything is just simplified for you. You just run the operation, do a major version upgrade. 15 minutes later, you get the new version with the data in it. If you're coming from different databases, we also have a service called DMS, which is Database Migration Service. Along with it, it has a tool called Schema Conversion Tool. So if you're, say for example, you're kind of like moving from Oracle to Postgres, you could actually use that. Also, if you're kind of moving from a very old version of Postgres to the latest version, you want to kind of like do a multi-version skip, or you want to move from an on-premise Postgres to RDS, you can use DMS. The way DMS typically works is like, you use the service and say, I want to create a new, you would create your new version of your instance and then use DMS to say, hey, use the schema conversion tool, copy the schema from the source instance, which can be Oracle or Postgres on-premise or an older version of Postgres, replicate the schema onto the new instance, and then in DMS start what is known as like the replication instance. And what it will do is it will connect to your source and your destination. You would select all the data that you want to move, and once you have selected, it will basically copy or migrate that data into your destination. On the destination side, it will give you an option. You can actually say, hey, append to the existing data if you already have data, or you can say, hey, truncate everything and start loading the data fresh. So kind of like a clean copy out there. So using that, you would be able to move like one big chunk of data migration out there. The added benefit of DMS, it also supports change data capture. So if you're doing a big migration, but there is still work that is happening, depending on the version of the source, it can actually enable logical replication and do change data capture. So like, while you're moving, which could take like an hours for moving like large database, the changes that are happening on the source will be kind of captured and then replayed back into your destination. So at the end of the day, basically, you can actually catch up at your own speed, and when the database is ready and your applications are ready to kind of like switch to the new instance, you would basically flip your applications to point to the new database instance out there. And basically, your migration is now pretty much click, 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 wait till it catches up, and then once you are satisfied, like everything has been caught up, you create like a small 5-minute maintenance window, flip your applications to now point to the new server and start again. And that's how you would actually do the migration. There are other ways of actually doing replication and migration in RDS. So typically Postgres does 2 big level, actually 3 in some ways. The physical replication, which is what like the read replicas and other are using behind the scene. With Postgres 10, there is support for native logical replication also. And you could also support like SQL-based logical replication using triggers and other like Sloaney we're using, right? Now, using SQL-based logical replication typically is a performance degradation due to the way the triggers are used as such. So in RDS, we also have enabled support for logical replication using various plugins. So we support test decoder, wall to JSON, decoder raw, and starting with Postgres 10, we also support the native logical replication it supports. Recently, for version 9.6 and 10, we are also supporting the PG logical extension. So all in all, basically on the source replication where you want to enable logical replication, you enable a parameter called RDS logical replication on, and after that you are able to use any of the inbuilt decoder plugins to kind of like do your own logical replication. I've seen people kind of write their own wall to JSON plugins and use it to kind of convert and push it to different data stores if they want out there. Apart from that, like what I've talked about is more on the logical replication and other things. Many people, what they're interested is how do you actually monitor the instances, right? One of the new features that we have enabled in RDS is Performance Insight. Performance Insight for RDS Postgres is available from Postgres version 10. And if you ask why 10, because 10 is where Postgres actually added a lot of weight type events, which would allow you to give, which would give you more granular data about a query on where it's using a CPU, where it's spending time on I/O. And Performance Insight really uses that weight events to kind of give you a runtime graphical utilization of your queries out there. So on that small example that you see out there is you have various queries running, and the green color shows the CPU usage that's caused by the query, and the blue color is like the I/O weights that is happening. Using this information, you can quickly narrow down like, where your queries are spending, what type of resources your queries are utilizing, and you can use that to kind of create like better query plans, like, maybe if it's too much I/O, maybe you're missing an index. If it's too much CPU, maybe you want to use like a different plans out there. So there are ways you can actually use that data to kind of do query tuning. Now, one thing that keep in mind is like Performance Insight does work in conjunction with PGStat statement. In fact, it is actually recommended to have PGStat statement enabled. So the PI actually does a better collection of the data to kind of display it to you. Apart from that, you can also use the other inbuilt CLI Postgres tools like auto-explain and other things. We do support them in RDS. Performance Insights gives you a view from the database. We also have like the enhanced monitoring that gives you the typical 50 top OS stats that typically people like to see. And this would be like the top output, the IO stats and other things. So what enhanced monitoring does is basically collects this 50 different metrics of your OS and gives you kind of a CloudWatch metric trail of that. So in the past, like what used to happen is like, hey, something is consuming my CPU. You would use your enhanced monitoring to see like what are my top queries out there. With PI, now you can actually drill down to the specific query on the graphical utility itself and kind of like look at which query is actually consuming the CPU. And that would help you to make the call whether do I need to tune that query, or if I cannot tune the query, maybe I need to like bump up the resources for that instance so it can actually execute it well. Right? All the data that I'm talking about is also pushed into CloudWatch. Now, if you know CloudWatch is like, it is kind of like a retainer of all your logs related to the instances. So everything that you see on the performance insight or the enhanced monitoring, they are basically being stored in the CloudWatch. So you can actually go into CloudWatch and keep your retention period on how long you want to keep the logs out there. Recent things that we have now added is we also now help you to push the engine logs of Postgres into CloudWatch. So say, for example, you want to kind of do your analysis, like you have, say, enabled PG audit as an extension, and you want to push the outputs of those engine logs into CloudWatch so you can actually pull it through a different system and run your auditing software on it, right? So we now support what is called like a logs upload to CloudWatch. By doing that, it will continuously stream push all your engine logs into CloudWatch, and you can go into your CloudWatch and either kind of push them to S3 or different ways of consuming it and run like any analytics that you want to run on the engine logs. So this one has been available for about like 4 months now. It is supported on Postgres 10.4 version onwards and 9.6.9 onwards. Now, whatever I've talked about, you can always kind of like, you may still have more questions. So we do support the AWS Forums. Now, we have different forums depending on your question type, but there is a dedicated forum for Amazon RDS. Like many of the people who are more users or some of the engineers at AWS are actively looking at this and responding to queries out there. For Aurora specific, it has its own forum, so you can ask questions like, if you want to kind of like get more details, like it is kind of something that you're stuck and you're not able to figure out, you can actually post that question and somebody can actually help you to kind of let you know what your next steps typically would be. This is again like a user-driven thing, so it actually relies a lot on other people, also other users helping out other users based on their own experience. With that, I actually want to kind of like make a logical stop for the first part of this session. I'll actually open up the floor for 5 minutes of questions, and then we can actually start the next session.
Спасибо. Микрофон, как вы помните, желательно задавать вопросы.
You should ask question to the microphone because everything is recorded, and if you speak Russian, ask question in Russian because we will have translation, and your question will be translated.
How fast you can switch between Postgres instances and AWS Aurora instances with Postgres possible?
So I do cover that in my next session, but I'll give you a quick answer. There are 2 ways to do that. You could actually do what is known as the snapshot install. So you would take a snapshot of your RDS instance and restore that to an Aurora instance. And the time it will take will depend on the size of the instance, size of the snapshot you have. Now, my most favorite recommendation is use what is known as the Aurora read replica from RDS Postgres instance. So what it does is, behind the scenes, it starts with the snapshot install, Once it has restored, it will open up a replication to your primary RDS Postgres instance and start streaming all the changes and catch up. So once the replica has caught up, now you can do kind of like the similar window to kind of promote and fail over to the Aurora Postgres instance.
And it works on each side. I mean, you can migrate from Aurora to Postgres and vice versa, yeah?
You can move from Aurora, RDS Postgres to Aurora, and to kind of like move back, you would use DMS as a way. That feature is not available right now, but it will be actually coming pretty soon now.
Oh, and probably another one question. Can you configure everything using about Postgres DBS using AWS CloudFormation?
Yes, you can do that.
Can you create users?
So the users.
Or it's better create snapshots on your.
So typically, the way I've seen people using it is they would enable IAM users through the CloudFormations and use the IAM scripts to kind of like use them. Now, mind you, CloudFormation gives you on the RDS CLized connections. So for the PSQL connection, you still need like an external way to kind of do that. CloudFormation really helps you to do the RDS API automation out there.
Thanks.
Спасибо за доклад.
Thank you for your presentation. I have a question related to logs of Postgres in RDS. As you know, now there is no possibility to take and manually delete a log. And sometimes it is very not inconvenient. It can cause problems. Can we, in the nearest future, hope that there will be some possibility to manage such logs? For instance, deletion of the logs, transmission of these logs, or doing something about these logs. Can we hope for this?
Right. So if your question is specific to the engine logs, using the CloudWatch upload, you can actually push them and change the retention period to kind of reduce it to a smaller period. Now, if you do have high generation of the system logs, then right now I think the option is maybe you can actually open up a ticket, but we are actually looking into ways to kind of see where we can, based on the disk usage and other parameters, actually give them more options as such. So I'll talk and try to understand, but right now the preferred option is to just push them to CloudWatch, so it gets it off the engine instance itself, and then you can actually delete it from the CloudWatch.
Я правильно понимаю, что если
Do I understand correctly? If we export logs to CloudWatch, so they are then deleted from the instance of RDS. Am I right?
Все, спасибо.
Thank you very much.
Thanks a lot for your presentation. You were talking about multi-AZ setup, but you only showed us like duo AZ, right? BIZ, right? The first one and the second one, but like in Postgres 10, they introduced like synchronous commit with like a lot of options. Any plans on doing like quorum stuff or something like that in terms of multi-AZ? Any plans on improving that? So
I cannot probably talk about like what the future plans are, but like think of it this way. So if you think that the multi-AZ, which is the two AZ solution, is not enough, you can actually look at Aurora, which does like 6 copies and actually gives you 6 ways of protecting the data. Now, what your real question is like, am I more worried about the durability or the failover? Because if you look at multi-AZ, it does give you 99.95% availability already. Now, is your question related to you want to go higher, or is it related to the durability of the data itself, right? So if you, multi-AZ gives you like, EBS behind the scene is mirrored, so you're already kind of like getting 4 copies of your data, so the durability is pretty high. And it's backed to S3, which means like you get the 11 nines durability of S3 also behind the scene. On the Aurora side, you actually get 6 copies, and the durability is still higher with the 6 copies. So there are ways to look at it. I think the question would be, what is your need? Is it high durability needs, or is it the high availability needs of that? So right now, we do support up to 99.95% as our standard supported SLA.
All right, thanks. One more, if I can.
Based on the time, yeah.
Do we have time for? All right. You talked about DMS service, and you showed how one can migrate from one region to another region via like logical replication and change data capture process, right?
Yeah.
But I'm asking, when you talked about switching for multi-IZ setup, from switching like from primary to secondary as a primary, you said that to read replica actually. You need to wait for it to catch up, and you said there's a CloudWatch metric for that. I wonder for DMS, for like switching to another region or another engine like Aurora, do you have like CDC metric that shows you like lag and if it caught up or
Right,
not?
so DMS uses the logical replication, and even for logical replication, there is a logical replica lag metric available in CloudWatch, which is what DMS actually uses behind the scene to see if it has caught up with it or not.
All right.
So that is
so
actually
you'll disable the. So what the process to give it?
So the way to think of it, like nothing in AWS will flip that switch for you, right? Especially because it is asynchronous. So even in case of DMS, it will catch up to the current replica, and you as a user will make the call, okay, I'm stopping load now, and now you can flip over.
All right. Thanks.
Yeah.
Thanks for
Последний в этой серии.
Thanks for the presentation. I have a question about third-party extensions. You mentioned that you support some of the extensions I saw, like
60.
PG repack. So is there plans to add support for like compiled third-party extensions?
So right now, the way it is, you would request extensions through email, which is called RDS Postgres extensions request at amazon.com. We do not actually right now support compiled extensions. Typically for that use case, we say you can actually deploy it on EC2 instance, because if you have a very custom extensions, it might be actually better to kind of host your own instance of there. Now, coming on the RDS side, we already support 60 extensions. So like if it's a popular extension, it might be already supported. And if it's not supported, you can actually request it. We do kind of look at it, and every time we do like minor version upgrades, we kind of look at the feedback and add more and more extensions out there. Yeah.
Все? Ну, давайте продолжаем.
Okay, all right, thanks.